Hi, this is Bill Denninger, VP of Products for BlackLynx. Today here at SC18, we're providing high-speed search acceleration through the use of x86 and FPGA technology. So let me show you how we do that. So we pulled down from the National Cyberwatch competition 15.5 gigabytes worth of PCAP data. And what we're going to do there is search that data in its raw fashion. No need to decode it, no need to do ETL and indexing. In this particular example we have here, we're going to look for a particular destination IP address, this 34.238 address, as well as we're going to do regular expression searching on the payload, 3 digits - 2 digits - 4 digits. Now we're looking for that because it's the clear text value of a social security number. So if you're doing PII detection, that would be a violation because it should have been encrypted. Instead, it was in clear text. So a little over 15.5 gigabytes worth of data in 5.1 seconds. That's a little over 3 gigabytes a second with a single server. That's the power of the x86 and FPGA technology we're using from Xilinx to get that kind of performance. You can see here we did a little display showing you the 4 social security numbers that were detected. So how fast is it? Sounds fast, but how fast is it? Let's do a comparison. 2 comparisons we'll do here. First one is running T-Shark on a single socket 22 core server. Doing that whole 15 gig, doing the same kind of search, took a little over 23 minutes to do, which is 2 orders of magnitude faster, 275 times faster than using T-Shark. The other approach is to actually use a decode. So I pulled down 1 of the gigabytes of the 15 and did a decode. It took 12 minutes to do that, which meant to do all 15 of those files would take 3 hours to do the decodes, and we haven't searched anything yet. So that's, quite frankly, not a real-time answer for the solution. That's the acceleration side of what we do. High-speed performance, making use of the Xilinx FPGAs and x86 architecture. The other half of what we do is our connector side. Our ability to bolt into various applications with ODBC and JDBC interfaces, as well as our RESTful JSON interface, to allow applications to benefit from that acceleration, quite frankly, without even knowing that FPGAs are inside the server that we're utilizing here. So in this particular case, this demo, we're going to use Splunk Enterprise, very strong market leader in the search business. And we're going to use our RESTful JSON connector to be able to hook up the searches that Splunk wants to do with the data and the parallel acceleration that we offer. So the first one we're going to do here is SSL certificates. So on that 15.5 gigabytes worth of data, we're going to look for the certificates that happened during that time. And you can see the ones that were issued by subject and one issued by the issuer, as well as a little slide down on the chart here. We can also tell you of these certificates that went by, how many of them are going to expire in the month of March of next year. And you can see 148 in this particular example would expire. So that's high-speed search at the higher level of the protocol stack. We also can do some video analysis. What we're going to do is we're actually going to watch a video of a parade that's got cars, buses, and trucks in it, and we're going to actually look at the types of trucks that appear and determine, is it a pickup truck, garbage truck, dump truck, or fire truck? And then we're going to actually generate alerts, which is what you see here on the display, for all the existing fire trucks or fire engines that we discover. So here's our video object detection and image class being demonstrated here. Here's the actual video pulled down from YouTube. We're actually detecting the objects. In this particular frame, there's a truck and a car with the probabilities of those classifications. And because we're looking for cars, buses, and trucks, we find these two. We want to do a deeper dive on that truck and determine what type of truck is it, garbage, pickup, etc. In this case, we're going to do what we call chaining, which is go from the object detection, crop the space of the picture, and then do image classification on it. In this case, we determined that that is a fire truck. That generated the alert that you saw back here on the previous page to the IT organization to understand what's going on. So at the end of the day, The BlackLynx solution partnered with Xilinx allows us to supercharge accelerated searches for various applications. Splunk in this example, it could be Tableau, Microsoft, SAP, Elasticsearch, etc. through those connector layer. Thank you.